Hi guys, Mrs. Gerhart here. I wanted to take a few minutes to show you how to write CER conclusions. This is going to be a really important part of your science class this year. CER stands for Claim, Evidence, Reasoning. So let's think about our gummy worm lab. If you don't already have it, I would like for you to grab it, get it out, because what we're talking about now is going to be how you write your conclusion. I want you to save that for the very end. So our lab question asked, how does temperature affect flexibility? In other words, how does the independent variable affect the dependent variable? So based on what you saw, what is the relationship between temperature and flexibility? Right. Most of you would have found that as temperature goes up, flexibility also goes up. And you kind of know this from experience. The warmer your muscles are, the more flexible you are. That's actually why most people say that you should do a quick, brisk warm-up, then stretch, then go into your physical activity. I know that a lot of us like to stretch and then do our physical activity, and they say that's not the best way to get our muscles ready. But how do we know this? How can we prove this scientifically? Because after all, you are in science class. And one of the hallmarks of science is that the explanations rely on evidence or data. And that comes either from direct observation or from testing. In this case, you tested your gummy worm. You tested its flexibility at 3 different temperatures. And obviously you had a control at room temperature. So this evidence or data that you collected is called empirical evidence. And scientific explanations can be tested or refuted based on other people's ability to replicate and get the same results in their data that you did. It doesn't have to be exact, but it should be a similar trend. So to do this, scientists write CER, or claim, evidence, reasoning. So for the claim, you are simply going to state your answer to the lab problem or question. You just state your response. Yes, no, maybe. As temperature increases, flexibility increases. Evidence. This is where you provide analyzed data to support your claim. Okay, this is just data. You are not actually explaining anything just yet. Your reasoning is where you do your explanation. This is where you justify your evidence. This is where you show, hey, my claim is correct because of my evidence. So here it is when we look at it all together. State your answer, provide data, justify. So I wanted to do a couple of examples with you just for fun. So this first one is super cute. It's an Audi commercial. And I want you to think about what the girl's claim is, what her evidence is, and what her reasoning is. If you don't have a piece of paper, go ahead and grab it. I'm going to show this once, but you may want to repeat it more than once.
I have evidence that proves my dad's a space alien. He speaks a weird language. He drinks green stuff. He says he's from Albuquerque. I'm not buying it. I mean, just look at him. And one more thing, he has a spaceship. The evidence doesn't lie. My dad's an alien.
The highly advanced Audi A6.
All right. So, what was the little girl's claim? Well, her claim was that her dad was a space alien. What was her evidence? She said that he spoke a different language when he was gargling. She said that he drank green stuff. She said he was from Albuquerque, but she wasn't buying it. And she also said, just look at him when he was wearing his bike helmet and his bike gear. But her biggest piece of evidence, she said, he drives a spaceship. So the little girl's evidence was that he spoke a different language, he ate green stuff, he looked funny, He said he was from Albuquerque and that he drove a spaceship. So now how does the little girl explain that her evidence supports her claim? Well, she said basically that if you speak a different language, you drink green stuff, you say you're from Albuquerque, you look weird, and you have a spaceship, you must be an alien. Okay, so that was her claim, her evidence, and her reasoning. Let's look at another one. It's fun. So this is a Doritos commercial. Make sure you're paying attention to the details in this one.
Honey, have you seen our cat?
Nope.
Have the Doritos. Have the
All right,
Doritos.
that's not the one I wanted to show you. The second one, at least. I wanted to show you that first one. Okay, so this time, what happened to the cat? What's your claim? What evidence do you have from the commercial? How does your evidence support your claim? So go ahead, pause this video, and I want you to write it down. What's your claim? What's your evidence? What's your reasoning? Welcome back. So most people think that the dog killed and buried the cat. Their evidence is that we see the cat's tags being buried. He slides the Doritos across that say, "You didn't see nothing." And we have the poster that the cat is in fact missing, as well as the woman at the end asking, "Honey, did you see our cat?" So how does your evidence support your claim? Well, based on the evidence that we saw, we can assume that the cat is missing. And based on the dog's behavior, burying the cat and then telling somebody you didn't see nothing, we can also reason that the cat is missing because the cat is no longer alive. The doggy took care of him. All right, let's look at a little bit more scientific example. So, how does the length of a pendulum affect how long it takes to swing back and forth 10 times? So you can think of this as like a tennis ball being tied to a string, and you are going to change how long the string is each time, and then count how long it takes for the ball to swing back and forth 10 times. So your claim should be that as the length of the pendulum increases, the time that it takes for it to swing back and forth also increases. What evidence do you have? Well, you could do an experiment. Lucky for you, I already did one. And here's my data in a data table. So you can see that I had 5 teams, and they took measurements for the length of the pendulum at 50 centimeters, 60, 70, and 80. And then the average time that it took for that ball to swing back and forth. So 50 centimeters, it took 14 seconds. 60 centimeters took 15 and a half. 70 centimeters took 16.9. And then 80 centimeters took 18 seconds. So as we can see, as the length increases, 50 to 60, 70 to 80, so does the time from 14 to 15 and a half to 16.9 to 18. What's the reasoning? Well, plain and simple, all of these values show that as time goes up, as length goes up. When we put it all together in paragraph form, it looks like this. We have 3 sentences here in this case. You may end up with more than 1 sentence for your evidence. You may end up with more than 1 sentence for your reasoning, and that's okay. So what I would like for you to do is write a CER conclusion for your gummy lab question. What is the relationship between temperature and flexibility? So answer the question in your claim, provide evidence from your data table and then reason your way through it. How does your evidence support your claim? Once you are done with that, I would like for you to go to the Nature of Science module on Canvas. I want you to grab the experimental design practice page / study guide. Work your way through that. You can use the Nature of Science module on Canvas as reference. You can also use the Green Book as reference. Remember that you have a quiz tomorrow. If you have any questions, please don't hesitate to send me a Canvas inbox. Have a great one, guys. Bye.